In this tutorial video, I will show you how to set up and use the Robot Learning Lab development environment using the Robot Learning Lab virtual machine. First, we need to go to the Robot Learning Lab website and here to the documentation. On the Robot Learning Lab virtual machine page, you can find information about how to set up the virtual machine. First, we need to download the virtual machine image by clicking here. The image file is rather large and I've already downloaded it before, so I'm going to skip the download for now. Once your download is finished, you need to start VirtualBox, which you need to have installed beforehand. In VirtualBox, click on File, Import Appliance. Select the previously downloaded file. Click Next. In this screen, you could adjust the settings of the machine you're about to import, but I'm going to keep the defaults for now. Click Import. The import process will take quite a bit, 1 or 2 minutes. Once the virtual machine has been imported successfully, we need to adjust its settings. Go to Settings, click on the Display tab, make sure the virtual machine uses all the video memory available, enable 3D acceleration, and depending on your operating system and version of VirtualBox, you might have different options available. In my case, I need to select this option for the graphics controller. Click OK to save the settings. And now we are ready to start the virtual machine. The virtual machine is based on Ubuntu and it contains a fully set up ROS melodic workspace. I'm going to change the screen size. As you can see on a desktop, there are different icons available. These will be handy in the development process. The virtual machine comes with the Robot Playground project, which is the initial starter project. We can run the Robot Playground simply by clicking on the corresponding icon. This will open a terminal window, which starts the Move interface and loads the project code. Additionally, RViz is opened, which will display a visualization of the robot. As you can see, the robot is already moving because our project code is being executed. In the example, the robot will be moved into different poses using all the available movement commands. It will perform movements by specifying the joint angles directly. It will move on a point-to-point based fashion and also perform linear motions. On the left, you can see the debug output, which gives you some hints about the position and the orientation the robot is currently moving into. Right now, it's performing a linear motion. Next, it will move point to point to the opposite side. And the example will be concluded by a random motion. Once the example code is completed, the robot will move back into its home position. As you can see in the debug output, the code executed successfully. For now, I'm going to close this window again, and we're going to have a look at the code we just ran and learn how to modify it. To modify the code, simply click on Edit the Robot Playground. This will open Visual Studio Code. And as you can see, inside the Hello World function, there is the code that has just been executed. It contains different movement commands such as move random, move joins, move P2P, and also linear motion commands. I encourage you to have a look at the code, read the comments to get a better understanding of what is possible and how to move the robot yourself. For now, I'm going to remove most of the code to make the example simpler. I'm going to keep the random motion. I'm going to change the logging output from hello Ross to hello RLL, and also I'll adjust the joint values. If you want to execute the modified code, make sure to save the file. I'm going to close Visual Studio Code again. To rerun the code, simply click on Run the Robot Playground again. Once again, the terminal appears. RViz is shown. And the robot begins to move. It will move into a random position first, followed by the move joins command. And this concludes our modified example. As you can see in the debug log, hello RLL is output. The move random command is requested, followed by a move joins command. Now, once you're happy with your code, you can go ahead and submit it to be run on an actual robot. To do so, simply click on Submit the Robot Playground, which will open a new terminal window and submit your code. However, as you can see, an error occurred because we didn't set up our API access config yet. To do so, simply click on the link. If you hold Ctrl and click on the link, it will open up Firefox for you, and we can go ahead and download the access config. To do so, you need to log in first. You can do so by using an identity provider or simply register using your email address. I'm going to go and log in with my university account. Once you're logged in, go to Settings, and here you can download your API access config. Save the file. The error message tells us to store the downloaded file at this location. So we're going to open a file browser, copy the downloaded file, and place it in the Robot Learning Lab workspace, into the sources folder, into the Robot Learning Lab SDK, the LL Tools folder, and finally inside the config directory. If we now click on Submit the Robot Playground again, once again a terminal window appears, but this time our submission succeeded. Now we can go ahead and view the status of our job on the Robot Learning Lab website. To do so, simply click on the link by once again holding Ctrl. This will open up Firefox and show you the list of your most recent jobs. Currently, our job is in the state building, which means it is being built on the Robot Learning Lab servers. Once the building process is complete, it will go into the simulation state where your code is executed in the simulation, and once the simulation succeeds, it will go ahead and be scheduled to be run on an actual robot. If we click on the View Data button, we will see some additional information about our submission. For now, only basic job details are available, like the submission date. Once our job has been built successfully, it will change status to running sim. And once the simulation is complete, we will get some additional information in the View Data tab. The simulation run should only take a couple of seconds. The page will refresh automatically, so we should see it right now. So we're in waiting for real. Now our job has started on the robot. If we click on the View Data tab, we can see the simulation log, which is the same as previously. If we now go back, we get a new View Live button where we can watch the robot perform our code live. Once our job is complete, we can see the result. In our case, it was a real success. If we go to the View Data tab again, we even get the video of the execution and the real user log. So we can watch the video again. As you can see, it is performing the same motions as in the simulation. So the simulation and the real robot run are really performing the exact same motions. And also the real user log contains the same entries and debug outputs as before. This concludes the tutorial on how to set up and use the Robot Learning Lab development environment.